All of you. In last video we discussed about the terminology of helical gears, spiral gears, and in that spiral gear also we go through some derivations. These derivations are the center distance between the two spiral gears and also efficiency of that spiral gear. So some terms are different. Some terms are different that of spur gear in helical gear and in that spiral gear. But that approach that to derive some formulas, approach to derive some formula that are same. But due to some inclination given to the tooth about that rotating axis, that inclination with that rotating axis of that particular gear, some terms are become some terms are modified with consideration of this inclination. And we go through in last video regarding some terms that terms are modified with consideration of that inclination of tooth with that rotating axis of that particular gear. So in last video we discussed about that center distance between two shafts for spiral gear, efficiency of that spiral gear. We derived that formula for efficiency of that spiral gear. Now almost all part is finished. Theoretical part is finished. We go through some numericals based on topics which we studied in that particular video in the gear to topic. So we already go through some basic numericals, very simple numericals to find out that addendum, find out that module, or find out the number of teeth. So for such simple numericals we go through the such numericals, simple numericals. Now we move toward this some numericals, more numericals. So we discussed in this video some numericals that we regarding that gear tooth. So first numerical first numerical here it is given. First numerical it is given as a here one pinion is given with a pitch circle diameter 18 centimeter with cycloidal profile mesh with internal gear. So internal gear arrangement is given. It mesh with internal gear wheel run at half the angular speed of that pinion. So speed ratio is given. Circular pitch is given 10 centimeter. Addendum is given 3.2 centimeter. Radius of that rolling circle generating the cycloidal tooth profile is a 20 centimeter. And they are asked to determine the arc of contact, maximum pressure angle, number of pair of teeth in action, and maximum velocity of sliding if the speed of rotation of the pinion is 2.5 radian per second. So here speed ratio between this pinion and gear is given, and one speed of that pinion is given. So we can find out that speed. We can find out the speed of the wheel. As per given condition. And also here that pitch circle diameters are given. That circular pitch are also given. Addendum values are given, and to generate that cycloidal tooth profile, radius of rolling circles are also given. So with this data we draw this condition. We draw with this data. We draw to like this. We draw this pinion and gear like this. So here scale is given as a 1 centimeter. We consider as a 8 centimeter on the drawing board, on the drawing sheet. And now with this, in this diagram you will observe that two rolling circles having some diameter is given. And with this condition we draw this diagram. With given data we draw this diagram. And here that addendum circle, now this A to B here in this diagram, here A to B, this A to B, this particular length is a tangent to the two base circle. And we are interested to find out this length. So it is always tangent to the two base circles, always tangent to the two base circle, and angle between this line and this line passing through the pitch point, this angle is nothing but a pressure angle. This angle is nothing but a pressure angle. So they ask also about the pressure angle. So with this given data in this numerical, we draw this on drawing sheet with a scale as given as a 1 centimeter is equal to 8 centimeter. 1 centimeter is equal to 8 centimeter. With this scale, we draw this diagram, and with drawing this diagram, we have to find way by the actual drawing of this uh, engaging tooth. We find out this pressure angle as a 18 degree. We find out this pressure angle as a 18 degree by actual construction of this gears, by actual construction of this gear tooth. So with this, by actual drawing, we find out this pressure angle. So it is one of the asking quantity. Now another quantity we have to find out. Another quantity they ask to find out the maximum velocity of sliding, and they also asked to find out number of pair of teeth in action. That we can find out as a arc of action divided by circular pitch. So we know these formulas. And they are asking as a number of pairs in action. To find out number of pairs in action, we have to find out the arc of action. Or it is a total arc of contact. We have to find out total arc of contact. So that we needed to find out the number of pairs in action. Total arc of contact, that we interested to find out. Now to total find out the arc of contact, we have to find out arc of approach and arc of races, and addition of both of this arc of approach and arc of races, which will give you the total arc of action or total arc of contact. So this arc of approach is nothing but distance that AP. This arc of approach is nothing but AP, and arc of races is nothing but PB. Arc of approach is A to P, and arc of races is a PB. Arc of approach is A to P, and arc of races is a P to B. And we are interested to find out this. AP and PB. So this we can find out by using that triangles. So this arc of approach is O to P. Arc of approach, that particular line A to P, we can find out as a O to P into angle of AO to P. Angle AO to P. So how you can find out this arc? How you can find out this arc length? This arc length we can find out radius into theta. Arc is equal to R into theta. Arc is equal to R into theta. So radius, we know that radius is O to P, and angle between this arc, angle subtended by this arc, is a angle of O to P. Angle PO to A. Angle subtended by this arc is a PO to A. So this angle subtended by this arc is a PO to A. So this angle by actual drawing, by actual construction, we know this angle as a 28 degree. Here also we know this angle as a 39 degree. By actual construction, we know this data. Or we find this data. And now we have to find out AP, this arc of approach AP. So O to P is given. This value is given. That O to P's value is given as a 20 centimeter, and angle AO to P in radian. So 28 degree, we know this 28 degree. This angle is a 28 degree. But you convert into radian. convert into radian by multiplying by pi and dividing by 180, multiplying by pi and divided by 180. So this arc of approach comes as a 9.34. This comes as a 9.34. Now similarly we can find out this arc of races. We can find out similarly arc of races as a O1p. Now here this radius arc of races is this PB. Arc of races PB. So how we can find out that arc is equal to radius here this is the radius and angle subtended by this arc. This means the angle, and that angle is measured as a 39. That angle is measured as a 39 degree. So with this given data or finding data by actual construction, we move further, and similarly we can find out as a arc of races is equal to O1p into angle PO1b in radians. To convert this radian, again we multiply with pi and divide with 180. Now with this addition of these two value, it will give you that total arc of contact. It will give you total arc of contact 22.94. Now this maximum pressure angle, again from by actual measurement, maximum pressure angle this will calculated by actual measurement. Now this number of pair in teeth is a now total arc of action or total arc of contact divided by circular pitch. So that will comes as a 22.94 divided by 10. So this circular pitch is given, this 10 value is given in your numerical. So that will comes as a 2.294. These are the number of pairs. So pairs are always in whole number. So this 2.29 we can consider as a 3 pairs. Now all asking quantity we have to calculate it here. Two asking quantity we already calculated here as a maximum pressure angle by actual measurement, number of pair in teeth by finding this arc of contact, and by considering circular pitch we have to find number of pair in teeth. That becomes as a 3 pair of teeth in contact. Now two quantities we find out here first and here second. Now third quantity, this is the third asking quantity. This third asking quantity is a maximum velocity of sliding. Now to find out this maximum velocity of sliding, we need omega 1 and omega 2. So omega 1 value is given as a 2.5 and omega 2 is a half of the pinion. Angular velocity of that gear is the half that angular velocity of that pinion. So that angular velocity of the gear now becomes as a 2.5 by 2. So it will becomes as a 1.25. 1.25 into this PB. This PB we consider this length. So this length PB, we consider this length PB, and with this multiplication of this length with that difference between that angular velocity, we will find out that sliding velocity. We have to find out the maximum velocity of sliding. Now by putting all these values, we will get this answer as a 0.165. So this is third asking quantity. So in derivation we derive this formula for maximum velocity of sliding for external gear arrangement. We go through that derivation. In previous video we derive this derivation for maximum velocity of sliding. In that maximum velocity of sliding we consider in that formula or in that derivation, there will be for external gear, this minus sign becomes as a plus. This minus sign, omega, instead of omega 1 minus omega 2, it will appear as a omega 1 plus omega 2 in external gear. Here in this example, this is a internal gear. It is a internal gear. It is a internal gear. So here this sign changes as a by minus. Sign changes by minus. So we consider this. And then we simplify this, and we will get a third asking quantity as a 0.165. So in this numerical, they asked to find out maximum pressure angle, number of pairs in teeth, and the maximum velocity of sliding. So we find out this. Now here many quantities are not given. Here they given data to construct that particular gear engagement. And by constructing that particular gear arrangement, we have to directly measure from this. We have to directly measure from this constructed diagram. And we measure this from this constructed diagram, that particular data, and that data we use in this numerical to find out the parameters. Now so this is the first example. Now second example. In the second example, a pinion of involute tooth. Now in the second example, a very limited data is given. And we cannot construct this with this limited data. With this limited data, we cannot construct that particular gear arrangement, that particular diagram that we constructed in last numerical. So sometime with given data, they actually construct that particular gear arrangement and then find out that particular data, or extract that data to find out the that unknown quantities. But this numerical data is given. And with that data, we have to solve, or we have to find out that asking quantity. Now in this numerical, one pinion of involute tooth profile is given, having 20 teeth, meshes with gear having 80 teeth. So these tooths are given for this pinion and gear. Pressure angle is given 20 degree. Module is given 5 millimeter. Now here in this numerical, if the addendum of this wheel is such that interference is just avoided, so interference condition is given in this numerical. Determine the addendum for pinion to give a contact ratio of 3. Now here contact ratio is given as a 3. And also determine the maximum velocity of sliding for pinion speed of 1000 rpm. Also determine the addendum of that wheel. So asking quantity in this numerical is a maximum sliding velocity, and find out the addendum of that particular wheel. Now to find out that addendum of that particular wheel, we need to this addendum. How we can find out that addendum? We have to know that addendum radius. And also we have to know pitch circle radius. Addendum radius and pitch circle radius, and difference between this addendum radius and that pitch circle radius is nothing but the addendum. This is applicable also for pinion, and this is applicable also for the gear. So we must know this addendum wheel radius and pitch circle radius of that particular gear. So task is here to find out this addendum circle for that particular wheel. So first we have to find out the addendum circle of that particular wheel. Now RA and R. So here this formula is shown here. So here this formula is shown. So this is also applicable for pinion and also applicable for wheel. So Ra minus R, Ra minus R. So this formula. To find out addendum for if for pinion, this will becomes as Ra minus R. So here this Ra value also not given, R value is also not given. So we have to find out this Ra value and R value, Ra value and R value. So this R is nothing but pitch circle radius, and pitch circle radius you can find out. Pitch circle radius you can find out by using formula of module m is equal to d by t. Module is nothing but a diameter, pitch circle diameter divided by number of tooth. Pitch circle diameter divided by number of tooth. So for particular tooth, how much the pitch circle diameter, that is nothing but the module. So module is equal to d by t. So d by t, that particular, now t values are given, tooth values are given, module values are also given, so m is equal to d by t. In this formula module value is also given, teeth value is also given. So remaining quantity you can find out, like this. D value you can find out as a like this. D value you can find out by with this formula, m is equal to d by t. Now d is the diameter. Here we are interested to pitch circle radius. To obtain radius, we divide it by 2. And this is nothing but a d value. This is nothing but a r value. This is nothing but pitch circle radius r. This is nothing but pitch circle radius for pinion. This is pitch circle radius for the wheel. Now, and by using this formula of module, m is equal to d by t. So put this value, m is given, t values are also given. So put these values 5 and 20 for pinion, 5 and 80. Module is same for both pinion and wheel. So 5 is same, but the teeth are different, 20 and 80. So put this value 80 here for wheel, 20 here for the pinion, and then that value becomes as a 50 millimeter. For pitch circle radius of the wheel is a 200 millimeter. Now again, so this we will find out the R value. This value find out the R value. Now to find out this RA value, we go through this. Formula. Now to find out this RA value, if you look at this diagram, this is the RA value. This is the RA value. And we have to find out this RA value. And here also we have to find out this RA value. This RA value for wheel, and this RA value for the pinion. Now to find out this RA, first by using this triangle, you can find out this RA value. By using this triangle you can find out this RA value. So here now O to R. Now here they find out. Now this RA value. So in this numerical, this RA value. Now again we can find out this RA value as a. This RA is nothing but a. In this diagram, this RA value is nothing but a O1F. This is nothing but a O1F for pinion. This RA value is nothing but a O1F. O1 to F for pinion. This RA value. This is nothing but this radius. This radius and this radius is same. This radius and this O1F. So we are interested to find out O1F, which is nothing but RA value. Now this O1F, how you can find out this O1F? This we can find out as a by considering this right angle triangle. by considering this right angle triangle O1QF, by considering this right angle triangle O1QF, O1QF. So this O1F, O1F, how you can find out? By considering right angle triangle. So O1F is equal to, O1F is equal to, here they write as a, this O1F is equal to O1F is equal to O1Q square, O1Q square plus QF square, and square root of this, it will give you array value, it will give you array value. Now here in this case, we have to find out this O1Q, we have to find out this O1Q value, we have to find out this O1Q value, this O1Q value find out here, this O1Q value find out here as a O1P cos phi. By considering this triangle, by considering this triangle O1Q is equal to, by considering this triangle O1Q is equal to O1P cos phi, O1P cos phi. Considering this triangle O1P cos phi. By now O1P, we calculated this O1P as this is a pitch circle radius of that particular pinion. Pitch circle radius of particular pinion we find out by using model formula. So O1P is known to you, phi value is also given, pressure angle is given to you. So with this data we can find out this O1Q value. You have to find out this O1Q value. Now unknown quantity now remaining is the QF. Now unknown quantity remaining as a QF. So this QF value you have to find out. This QF value is nothing but this QF value. Unknown quantity is QF. Unknown quantity is Q to F. This QF is nothing but a arc of contact. This QF, this is nothing but a path of contact. This is nothing but a path of contact. Now how you can find out path of contact is equal to, now to find out this QF value, this arc of contact divided by cos phi, arc of contact divided by cos phi is nothing but the path of contact. Arc of contact divided by cos phi is nothing but a path of contact. So arc of contact we have to find out. Now here contact ratio is given. From that contact ratio we have to find out the arc of contact. Now contact ratio, we have this formula for contact ratio. Is equal to, and this is given as a 3. So arc of contact divided by circular pitch. Is nothing but a contact ratio. And this value contact ratio is given as a 3. Circular pitch is, we know this circular pitch as a pi m. Circular pitch is nothing but a pi into m. So m value is known to you. So circular pitch is known to you. Now circular pitch is known to you, 3 values known to you. So in this formula unknown quantity is a length of arc of contact. So we find out this length of arc of contact by using this formula, and with this length of arc of contact we put this, now here in this formula we put this path of contact. Now this path of contact QF, is equal to, now becomes as a, this arc of contact divided by cos phi. Is nothing but a path of contact. So path of contact divided by cos phi is equal to arc of contact. So this path of contact now becomes as a, this arc of contact into this cos phi, arc of contact into cos phi. So put these values of this arc of contact, arc of contact is 15 pi. Arc of contact is 15 pi. Put this value here, 15 pi into cos phi value is given 20. So this, with this given data, it comes as a 44.28 millimeter. So with this we move further and find out this array value. Now QF is known to you. Again O1Q is known to you. Now put into the formula, and you have to find out this RA value. You have to find out this RA value. Similarly, you have to find out for the gear. Similarly, you have to find out for the gear that particular addendum for gear. Here we find out the addendum for pinion. Similarly, with similar approach, we have to find out addendum for the gear, and these are the asking quantity. These are the asking quantity. Find out that addendum. Of that particular wheel and pinion. Now, remaining asking quantity is a maximum velocity of the sliding, with the same formula that we observed in the previous numerical, but here it is a external gear. Here these are the external gears. So for external gear, this formula is now becomes as a plus. This sign is now become plus. This sign now become plus. So in previous example, this sign is in minus. And this again PF we find out by using similar to our previous example. This PF value, this PF length, again you can find out by a similar approach that we observe in the previous numerical. So omega 1 and omega 2 are given. Omega 1, 2 are given. Now you have to find out this PF value. You can find out by similar approach, and this is nothing but a QF minus QP. This PF is nothing but a QF. This value is nothing but a total value minus this QP value. It will give this value. So we know this QF value. This QP value now find out by this triangle Q2P value. Now you can find out Q2P value. You can find out by using this triangle O1QP. Now this QP value is nothing but a O1P sin phi. This is nothing but a O1P sin phi. This QP is equal to O1P into sin phi. So O1P is nothing but a P circle radius that we already calculated. So this QP is known to you, QF is known to you, so PF is also known to you. Now with this, put this value here, and you can find out the maximum sliding velocity. You have to find out maximum sliding velocity. So these are the asking quantity. Now in this numerical, we directly not construct that gear arrangement, but in previous numerical we construct that gear arrangement, and whatever the data required we I extract from that constructed diagram. But in this numerical, the data is given, and from that data and with our usual formulas, we simplify and find out that asking quantity. So in these two numericals we go through this video. Some numericals we go through again, some numericals in next video, and then we stop. Now in this particular numericals, if you observe, these are the interference conditions. Here they consider as a interference conditions. And for this interference condition, we have to draw this diagram. So for this interference condition, this addendum of this particular gear, cut the base circle of this pinion, and we obtain these 2 points. Q. Now here we obtain these 2 points Q and this point. And for simplicity, we consider this Q point, and we draw these triangles. And from this triangle, we have to find out that particular arc of approach, path of approach, path of recess, and total summation of path of approach and path of recess is nothing but a path of contact. So we find out this by considering this diagram. But point of view here in this example is that these are considered interference cases. In interference cases, this addendum of particular gear is cut this base circle base circle of that particular pinion. Similarly addendum of this particular pinion, it also cut the base circle of this gear. And we will obtain some point. Here. F point. This F point we observe here, obtain here. And same approach is we observe in this internal gear also. So both the numericals are based on the interference cases. So we consider maximum addendum diameter. So in derivation, this condition is not very first derivation for sliding velocity. For such derivation, we consider a normal case. But here in this case, or in this numerical, we consider interference condition. So this we consider maximum addendum. Value. So with this two numericals, we stop here, and in next video we again discuss some numericals, and then we move further for the next topic.